Hi everyone, my name is Pedram Navid. I am the head of data engineering and DevRel here at Dagster Labs. And today we're going to be talking about automation, which is really the core functionality of any orchestrator. And we'll talk about kind of why that's interesting and why that might be kind of fun to think about. So Dagster is a Python data orchestrator that lets you build world-class data platforms. You can really run and monitor your pipelines using Python code as your source of truth. And it's really a data-centric orchestrator. And what that really means is if you've used orchestrators in the past, they've often been task-based. They've been more focused on doing a specific thing rather than talking about the asset that's being produced. Dagster flips that around and says, don't tell me about the tasks that you want to produce, but rather talk to me a bit more about the assets that you care about. And when you do that, you get a lot of nice benefits downstream from that. You get things like data lineage, you get things like the ability to do data quality checks, you get a data catalog for free, all this kind of fun stuff. So it is really a mind shift, but that's really what I think is underlying a lot of Dagster's fundamental power. And we'll kind of see that at play in a second here. So why automation? It seems almost like a silly thing to talk about when it comes to orchestrators. Like, yeah, duh, we automate things. And why? Well, we don't want to do them manually, right? You don't want to go in there and try to find, what script to run exactly at 5 o'clock every single day. That doesn't seem, that useful. And really, we've been doing automation ever since cron existed, right? So it's not really a new thing. But the reason I want to talk about automation today is that there's actually a bit more to it than just, running something on a schedule. It turns out when you have a complex data platform, you start to have very complex and different needs, right? Not everything will fit into a nice clean bucket, right? It may be that some things need to run on a schedule, but you may have to also respond to external events in different systems. You may have to meet some stakeholder need at some type of freshness, and you may want to balance different needs between, refreshing data too often and not enough in terms of controlling cost. And one thing that we've noticed at Dagster is if you can build some of this stuff declaratively, then you can really simplify how you approach building pipelines. Really, what you're trying to go after is this, Goldilocks of orchestration, where you don't want to materialize your assets too often. You don't want to like compute too much, but you also don't want to go too infrequently. You don't want to waste money computing things that aren't going to be seen or used. But at the same time, you don't want your stakeholders being upset with you because data is always too old and not relevant to them. So it's always about striking this balance. And that's what really Dagster offers, right? It gives you this ability to have state-of-the-art flexibility in how you build your data assets. And the way we do that is through three key foundations. We talk about schedules, we'll talk about sensors, and we'll also talk about auto-materialize policies and kind of what the difference between these three things are. And then we'll jump into some code examples to show you how it all kind of works out. All right. Schedules. We'll start there. I think this is a simple thing to understand. At the end of the day, a schedule is, this regular interval where you want some job to run. And in Dagster, that's really all you have to provide. You provided a job, which in a sense is just like a subset of assets. You typically don't want to run every single data asset all at once. You usually want to select, a portion of that you care about, and you want to say, run this, every day at 5 p.m. That's all a schedule is, and we definitely support that. And in terms of code, it looks like this. Now, you don't have to worry too much about what's going on in here. We'll jump into the code in a second. But all you really need to see is that we define a job by telling it what is the asset selection. And here we're selecting the bird feeders table, but you could imagine selecting multiple tables. You could say stuff upstream or downstream of this table. We've kept it simple in this example. And then once you have that job, you attach that to a schedule and you say run it at this particular cron schedule. If you're not familiar with cron, it's a very, I think, simple and compact way of defining a schedule. It's quite flexible too. You can define, things running every day at midnight, every Tuesday, on the hour, every hour, sort of whatever you think it makes sense for your business. But it is pretty much a fixed schedule from that point on. All right, so we talked a little bit about schedules. Let's talk a little about sensors as well. Sensors are based off of events that are happening, right? This might be, for example, there's an FTP server that you have to read off of, and you have a vendor, and the vendor says they're going to upload a file there every third Tuesday, except on Easter. Then it's the second Monday before the Greek Orthodox holidays, right? So it could be really complicated situations, and you might not be able to put a clean schedule on for that. And so what you might do is you use a sensor, right? A sensor is just a way of monitoring an external system or situation for something that changes. And once that change happens, you can trigger a run request, which is really just a request to run something. And it targets a specific job. So very much like a sensor in that, or a schedule in that sense, and that we have this job and we want to run it, but we don't have a fixed schedule. And instead, we're going to wait for this event to happen. And one thing that's a little bit different, a little bit tricky about sensors is because you have this like pull that's happening, like every 30 seconds, you're checking this folder. When that file comes, the first time it comes, you obviously want to create a run, but every 30 seconds, that file will still be there, and you don't want to run every 30 seconds. So we use a cursor, which is just a way of managing that state. And I'll show you how that works in Dagster as well in a minute. So this is like a rough sort of outline of how we build sensors in Dagster, and we'll dive into the code shortly. But in essence, we have this little asset decorator called @sensor, and we take that and we provide really a function that's going to read the previous state, make up some current state, and then process some things when they are new, essentially, right? If it's a new file or an old file got modified, we can, have some logic in there to create a run. And then once that's done, we save the current state to the sensor, and then the sensor will now pass that the next time it runs and it pulls. And we'll see how that works too. And then last but not least are auto-materialize policies. These are a declarative approach to scheduling, right? So it actually simplifies a lot of things. When if you think about it, at the end of the day, a lot of our assets, we want to update them when new data is available or if it's missing. And so a auto-materialize policy says, let Dagster take care of all the details of when these things run. Just run it when it's ready. When things are ready to run, go ahead, update it, and just call it a day. And so they're actually quite simple to implement. It's just literally one line, auto-materialize policy. And here we have the eager policy, which is our default policy. And all that means is it's going to update your assets if the parents are updated. So it keeps that data fresh. Okay, I talked a lot about kind of the different concepts, but let's talk a little bit about what we're actually going to build together today. So we've got a data set here that's pretty simplified. It's based off some bird data. We could imagine, we have this bird feeder table, which is, some checklist, some file that comes in at some, undetermined time. Birders, they're not really on a schedule. They just go out when they go out. They submit their file when they're ready. They're having a stroll. You can't really rely on them. So this bird feeders table, it needs to read from these checklists, but you never know quite when that data is going to be there. And then we got bird codes. That's just a mapping table. It doesn't really change. It's just a mapping table. We've got a CSV file there, and we're going to help map these files together. And then finally, we have a bird aggregates, which takes these two tables together, joins them all in DuckDB, and it's going to go really fast, like incredibly fast. These are millions and millions and millions of rows. It's going to join, aggregate, combine together. And this could be like a process that we kind of want to keep up to date as much as possible. And then finally, we got this bird notebook, right? This is a data scientist. They're going to do some bird forecasting. They're really bird-brained. They're spending a lot of time thinking about birds. And they've got this notebook that takes this aggregate data and creates some bird model, some bird forecasting. And, data scientists, they think they need their data updated all the time, but this thing's really expensive and we don't actually think anyone's using it. So we'll update this maybe once a day, and that should be enough. Like, we don't want to update this too often. That's sort of the world we're going to play in today. So given that, let's do a little demo. There's a link here if you want to download the code. It's all up there as well. But for now, we're going to show you some code. So give me a give me a thumbs up if you can see my VS Code. I don't know how good I am at sharing. A thumbs up, perfect. Okay, so we're gonna do a few things. What are we gonna do? I'm gonna start Dagster in the background just so we have it. We'll do that, and I'll talk a little bit about our assets. So maybe I'll shrink this guy here. And is this yeah, I can post a link. Someone will post a link in the chat, not me. Is the font size good? Can I get a thumbs up on font size? Okay, we are good. What we're going to do is talk a little about the assets, right? So I'll go back here. We have this bird codes, this bird feeders table. Those are our main assets. Then we're going to join them in bird aggregates, and then we're going to do our little notebook in bird notebook. So VS Code, where are you? Bird feeder table. This is our big, chunky, meaty asset, right? This is where the magic happens. We're going to get some data from our bird data folder. We're going to pass it this file that's going to come at some point in the future. We don't know when. And we're going to do two things, actually. It's kind of fun. What we're going to do is make sure that we first create a temporary table and we load that data using DuckDB into a temp table right here. And we're going to give it the file name and we're going to do a couple things like clean up some data and we're going to read it from the CSV and that's it. So far, so good. The next thing we're going to do is we're going to create our main table. If it doesn't exist, the first time we run this, it won't exist. So we're going to create it. We're going to use our schema from our temporary table, right? Nice and simple. But the second time and the third time this runs, more files come in. This table will be our main table. It'll contain all the data from all the checklists. Next thing we're going to do is we're actually going to delete some data from that table that we just created. So the first time there won't be any data to delete, but what we want to do is if we run this, asset 100 times for the same single CSV, we don't want duplicate rows, right? We want one set of data from that CSV file. And so the way to do that is we're going to delete everything from bird feeders where the file name matches the file we're reading right now. And if there's nothing in there, nothing gets deleted. And immediately after we do that, we insert some data, right? We're going to throw some data in there and our new table will be up to date. And then we can get rid of the old table. And then when we're done that, we're going to do some metadata stuff, right? We're going to count the number of rows. We're going to get some other metrics and we're going to just create some metadata here that we can now see in the Dagster UI. That is our big chunky one. We also have bird codes. So bird codes is just reading a flat file. This file doesn't get updated too often, so I've just hard coded it in. You can imagine you could have a sensor as well if you wanted for this, but for now we'll just call it a simple file that doesn't get updated. And because it's so simple, we can just, replace that table every time we read this asset. Nice and simple. Now we got these two tables. We want to join them together. We want to get like the American English name. We don't like species code. It's not that fun to read. So we're going to join that with the species and we're going to do some aggregations. We have, I think 2 million records in the first file. We're going to have 5 million in the next one, and it's going to keep growing from there. So we could easily have 10, 20 million records in here. And we're going to start to aggregate all that data to be able to count the number of birds, which we love to do, how many average birds, the median birds, that type of fun stuff. And then we got this aggregate data. We can actually preview some of this in Dagster as well. So I'm going to create a little query here. And what this is going to do is take 5 records from my little query that I built and add that to Dagster as a little preview. And we'll show you what that looks like. So that's going to be fun. And then we're done. Well, no, we're not done. We have our bird notebook, our bird-brained IPython notebook. I won't even show you what it looks. It's just like a bunch of, charts and graphs. Data scientists, that's all they ever do, right? They count stuff, whatever. We're going to build this in Dagster. We use Dagster Mill to do it, just a very simple way to run a Dagster notebook, and then we'll get the preview in the Dagster UI. So that's the bulk of what we're going to do. Now let's get into the fun part, which is automation, right? First, we're going to do sensors. No, I lied. First, we're going to do schedules. So it's the simplest type of automation, right? We want to run something on a specific schedule. And so I mentioned this before. To build a schedule, you need a job and you need a cron schedule, an expression. And so our job, I can go here. It's very simple. We got our notebook job and it selects the bird notebook asset, which is right there. And it's called bird feeder job. And we go to our schedule. We've got the schedule, we got the job, and here's this cron schedule, which is daily at midnight. So that's very simple. Let's open up Dagster and let's see what it looks like. So we've got our assets. We can go to the global asset lineage. We can see everything in here. Let's refresh that. Okay, we got some data in here. And what we're going to do is, where's my schedules? There it is. Actually, I lied. What I'm going to do is clean everything up and then run it again. So it starts from fresh. Live demos are fun. Okay. There. Now we'll pretend like nothing has ever run before. And yeah, this is the first instance of us running Dagster. So nothing's been materialized. We go to our schedules and we see the schedule's not running. So what we can do is just click this little running thing and now we just have to wait, right? So this is at 12 a.m. UTC. So we're just going to wait a little bit until that time comes, right? And then we can test our schedule and make sure everything's working. So if we put our mouse over here, it says 4 p.m. Pacific. It's 10:45 right now. So in about 5 or 6 hours, I think we can test the schedule and we'll be confident that it's working, right? So we could do that. That might take a little while. So instead, what we can do is just pretend. If we jump into our schedule, we'll click test schedule. We'll pick a time. We'll pick a date. Let's pretend it's Valentine's Day, and we'll run it. And this will open up a launchpad for us where it just pretends, it's the future. We can just time travel like that. We click launch run, and now it's going to launch that notebook. And because this is a live demo, it's obviously going to work. Actually, it didn't work. No, I'm kidding. I knew it was not going to work because if we go back to our asset lineage, how could this work when this hasn't done yet? So what we did is we created a schedule, we ran it, it failed. That's fine. We'll get to notebooks later. What we realized is we actually need data before we can run the notebook. So we go here, right? We've got our bird codes, we've got our bird feeders table, and we think about it like these are going to be files that someone's going to drop into a location. Today, it's going to be on my local drive, but you can imagine S3, FTP, it would work exactly the same way. So we will go back to VS Code and we will look at sensors. So we talked a little bit about sensors, right? A sensor targets a job, and here we're targeting our bird feeders job, which is just those couple tables you saw earlier. We tell it where to look, which is this data, bird data folder, and right now it's empty. And then we do this fun thing with state, right? We look at state and we say, is there any state currently? When you first run a sensor, there is no state, so it's going to be empty. But what we're going to do is process these files. As they come in, we're going to save the name of the file and when it was last modified to our state. And then what we'll do is see, was this file in previous state? Did it exist before? Have you seen it before? If not, don't. If not, then do something with it. Or was the file there, but is it now changed? Is it new? Did someone update it? If either of these two conditions are met, what we're going to do is ask it to run. So this is a run request. Our run request is going to target that job. We pass a little bit of a configuration in here. We just give it the file name. That file name gets sent to our asset, and the asset will process it. So this all sounds great. Will it work? I hope so. Let's find out. So I can, don't look at that. I will open up a new folder, or new terminal, and where are my files? So I have them here, downloaded data. We're going to take one, let's take 1988, and we're going to copy that exactly there. And then we're going to go into that folder, the bird data folder, like that. And we're going to unzip this file. And this is going to hopefully create that file. And what Dagster is going to do, hopefully, if everything works out well, is it's going to check that location to see if the file is there. We go to our sensors tab here. We click running, and we look at our bird observation. Oh, and that was fast. As soon as it saw this file, it saved it to the cursor. So now it knows about this file has existed, and it's also requested that run. So we can look at this run. We can see it's complete. We can see the assets. So here it is, the table name, the schema, the column count, the size, the number of rows. That's all that metadata we had earlier. That's all been created. So that's fun. We go to our global asset lineage and we see that, we're partially done, right? We're almost there. Now, the next thing we want to do is make this run, right? Well, we could do it manually. We can come here and click materialize, but that's not fun. So what we're actually going to do is use auto-materialize policies to make this run whenever its parents are updated. So to do that, we open up VS Code and we go to our asset. And I'm going to shrink this again. And all you do is add this one line, auto-configure for this asset. And that's it. So why did it not run? Well, you have to turn it on. The first time you do this, we go auto-materialize. We click running. And now it's going to wait up to 30 seconds. It's going to see, oh, there it is. It's like, yeah, this parent was updated. Let's launch a run. We click on this run. We can see it was done. It was so fast. And here's that little preview I was telling you about. Look at that. We have data. Isn't that fun? We have some data up to 1995. We got the species, the number of birds. things are looking good. So now we open up our global asset lineage. And now we're feeling pretty confident, right? We can wait until 6 p.m. and we're sure this is going to run. Or we can just click on here, click materialize selected. We'll do a manual run and we'll watch this go. And hopefully everything works out well. Wow, it did. That's amazing. We go into our asset lineage, we can click on it, everything's green. We love green. We can even see the notebook that was created. And here it is. It has data up to 1985, so it's nice. Numbers are good. We got goldfinches, we got house finches, we got sparrows, we got juncos, we got doves, we got all kinds of birds. So these are how many birds were observed in that data set, right? All good, but I mean, is it really working? Like it's kind of hard to say. Like it feels like it might be working, but we're not 100% sure. Let's open up our friend VS Code one more time. And we're going to do some more data stuff, right? We're going to go back in here and we're going to go back a folder. Let's copy, I don't know, all of them. Will that work? Who knows? We're going to copy all of these to project, dev, project, data, bird data. And I'm going to say yes. And then we're going to jump back in here. We're going to go back in my folder. We're going to go into data, bird data. I'm going to unzip everything. Can we unzip everything? Is that allowed? Okay. We'll unzip one at a time. You know, zips are hard. We'll unzip 1986 and we'll unzip 2001. That one's a big one. We'll try 2006. That's probably really big. There it is. Okay, so these are happening, right? Let's jump back into sensors and see what's going on. Um, let's click this guy here, and three new files were found. So, Dagster is just processing. I don't have to think about it anymore. I just know I put a file there. Things are going to work, right? We got this going. We got one file in. Hopefully, these other two are also successful. Uh, I haven't actually tried it with three at once, but I think it's going to work. It'll be fine. And we go into our global asset lineage, we can kind of watch these things happen. As this gets updated, you can see there's a little upstream data little tag here. And what that says is like the parent's been updated. This needs to be refreshed. And so it's going to wait for that to be done. And then Bird Aggregates is going to get updated as well. And then same with Bird Notebook. Now, Bird Notebook is on that schedule, right? Because we don't want to waste a bunch of compute calculating this every single time. So we're not going to update this until everything's all done. And we can kick that off manually. And that's it. That's sort of Dagster, just doing things for you, making things simple, automating things. And once this is done, we'll do one last check on the Bird notebook, and hopefully everything works. We can click here, we'll materialize this, and we can look at our run. And if everything works out well, we'll be very, very happy. Look at that, all done. So we can do this. We can come here. We can look at our new notebook, and it's got data up to 2005, more birds, so many different types of birds. So we're very happy with that. All right. I will pause there. Actually, I will go back to my slides. I lied. Um, yeah, I'll pause there. If you have any questions, feel free to chime in, pop in the chat, or unmute yourself and ask a question. And if not, feel free to join us in our Slack, sign up for Cloud, get the newsletter. Definitely star the repo to let us know if you enjoyed this presentation. Yeah, thank you all.
Thank you.
I do have one quick question. Do you guys have auto-materialize policies that work around a change like code version? So if you were to say push a new code location, and you want the asset to update on those cases, is there an option for that?
That's such a good question. I don't know if I know the answer off the top of my head. Um, I don't know. I don't know, but we can find out.
Hey, Pedram, you got a question here in the chat from Jacob. Is there a reason why you didn't use any IO managers instead of doing all of the steps yourself in SQL?
Oh, yeah. I didn't need an IO manager, so I tend not to use them. IO managers are great if you have like a simple pipeline and you kind of want to fit the mold of the IO manager. But IO managers also make a lot of decisions for you in terms of like what the schemas are going to look like, how partitions work, all that kind of stuff. And so they work fine, but I find sometimes if you use an IO manager, you can quickly like hit the limits of where you want to go with them. In this use case, an IO manager probably would have been just fine, but I just prefer the control I can use with when I do SQL myself.
Thanks.
Cool. Question here from Patricia. Can sensors check if the file with the same name changed?
Yes, actually, let me show you. Ours does do that. If I open my sensor, I do two things, right? So a sensor really is up to you. You can anything you can do in Python, a sensor can do essentially. In our case, the context is just a dictionary, and that dictionary is a dictionary of the file name and the last modified time of that file name. So what we do is, where is it? We get the last modified time for that file, and then in our dictionary, we take the file name and we give it the last modified time. And then when we decide if we want to run it, we say, if a file name's modified time doesn't match, that means, it should be newer, then run this request. So you can specifically say only run things when, new files arrive, or if a current file has changed in some way.
Great. I hope that answered the question for you, Patricia.
Yeah, thanks a lot.
Great. And Pedram, presumably these are extensively used in the Dagster Open project. Do you want to just mention what that is?
Yeah, that's actually a great one as well. Dagster Open Platform is a public repo where our not entire, but most of our internal data engineering is actually made public for you all to take a look at. So it's the Dagster Open Platform in our repo, and everything that we use internally from like our cost reporting, cloud usage, health checks, all that stuff is available for you to take a look at. So if you ever want to see what real data engineering looks like, if you want to laugh at, my poor data engineering skills, you can come in here and see how I comment out stuff sometimes and create data assets that way.
Great. Question from Danny. Is there a Dagster plugin for Slack email for alerting, I assume, for when sensors, jobs, auto-materialize one?
It's actually natively supported in Dagster Cloud. I don't know if you can get it in Dagster open source, but in Dagster Cloud, you can do Slack. I believe you can do email as well through alerting. And if not, you can always just create your own alerting system through Dagster as well.
Great. I think this is a question from Richard. Maybe it's a statement. It says, it would be great to see the auto-materializations appear individually in the overview activity page rather than just as ad hoc materializations. And the question is this planned or is there a better way of doing this?
There is something planned for, I don't want to give it away, but we are going to improve auto-materializations in Dagster. Look for that over the next few months.
Great. And Marco asks, what is the best way to create assets at runtime?
That's a hard question to answer. I think we'd have to spend more time talking about exactly what you want to do, but you can do dynamic assets.
Got it. A question to be asked in Slack, I guess.
Yes.
A question from Jacob. Is there a plan to increase sensors timeouts of 60 seconds? I often reach sensor limits when trying to look for freshness policies of multiple assets at the same time.
I don't know the answer to that question. If you are hitting limits, I would say definitely post it a GitHub issue or a GitHub discussion, or for a search to see if there's one already. If not, feel free to create one, and then we can sort of start to get feedback from people who are also facing that issue, and then we can prioritize that way because we do use GitHub issues and discussions to help prioritize what we work on.
Got it. Is there a way, this is a question from Lucas, is there a way to run a job anyway after a specific time, even though the sensor wasn't triggered?
Yeah, you could have two, right? Well, it depends on what you mean by after a specific time. You could have a schedule on a specific asset as well as the sensor, or a schedule on a job in this case, and a sensor. And so your sensor could be monitoring, but you could have a second schedule on top of that job as well to run every day, for example, at the minimum.
Right. And Keshav asks, is there a way to skip sensor run if the scheduled run has been triggered recently?
I think there's a way. I think my suggestion would be go to our Slack channel, go to Ask AI and ask that question. It'll search for a GitHub issue or discussion that I think I've seen on this exact question, but I can't remember the answer off the top of my head. And then if
Great,
not, post it. Yeah, so actually let me talk about Slack. A great place to also take a look at is if you join our Slack channel, go to ask-AI. It searches all our GitHub issues, all our GitHub discussions, as well as our help and docs. So if you have questions that you haven't been able to get an answer to, you just want to quickly check with something, it's a great place to start to get insight into whether or not that's already been asked.
Right. Question from Denton. So say I have a table in a database that is regularly updated. Would auto-materialize be the best way to materialize assets that are sourced from that particular table? And does Dagster know when the source table is updated?
I think you'd want a sensor in that case, right? Yeah, I think you'd probably want a sensor to check to see if that table has been updated. You could probably check to see if like the updated at column in that table meets some threshold, and then decide whether or not you want to run a sensor that way.